Hello, friends. Welcome to Animation Lab. I'm Rahul. Hope you all are good. Guys, today we are going to discuss one of the very important and very interesting techniques in big data to handle the large data set and joining of the two data frames. So let's start. So first of all, this is the conceptual diagram of the concept like broadcast has joined for efficient joins. And if in this diagram, I will explain you the concept of what is a broadcast joining, which is used in big data so that we can give high performance, optimized performance with the query, with the result set, the timing, the time complexity. In this diagram, you see there is a large data frame, and many a time in data modeling, we go for the like a star model or a snowflake model and a star model, where we are having multiple dimensional tables and a single fact table. So we generally see that all transactions, all that accounting and all those details of the transaction, everything that are those have the measurable columns or the attributes, and that data is huge, right? So on the left side, if you see that we have a large data frame, and that large data frame resides on some working nodes, right? So the concept is that we have a small data frame. Like here, we are taking example of transaction data and customer data. So we might have a small number of customers, and that data is ready. So we may be having some MBs of data of our customer data frame, and we have transaction database maybe for the last 3 years, 4 years, whatever. So that will be the huge data. So here we have large data frame, and that is we here we call it as for the understanding fact table, and we have here like dimension tables. So small data frame is the like dimension table called as, for example, customers. Like there will be few customers, very few customer, like 5,000 customers, like 10,000 customers, 15,000 customers. So we have in this data frame we have a data of the only customers, and in the large data frame we have data or the huge legacy data, transactional data, right? Historical data of the transactions by the customer. So what happens in broadcast hash join is the concept where like small DF is broadcasted. It means what is broadcasting? Providing that particular resource to everyone, right? That is broadcasting. So it populates and give it to everyone. So this is the broadcasting. So it broadcasts this small data frame to every of the work node, and once it makes the copy of small data frame, because making copy of small data frame is easy, right? rather than rather than copying this large data frame, collecting it from different nodes, aggregate it, summarize it, and then join that large data frame with the small data frame, is definitely it is going to affect the time complexity, as we have to avoid the costly shuffles. We have and there is a network, so we have to avoid network traffic for the transfer of the data of large data frame to small data frame. So the idea is we will join the small data frame to the large data frame. But what happens in PySpark, for example, in big data, when we join the small data frame to a large data frame, the large data frame resides itself into the node. It never gets shuffled. And the copy of small data frame is provided for the joining Here, as you see, worker node, and copy of all small data frames is provided to the all worker nodes. That is called as broadcasting. Once the successful joining happens into the background on every worker node, then a final hash join that gives us a joint result, and this is how we get the optimized, time performance. So let us see. I will explain you the code uh, uh, now. Hi. Yeah. So, guys, I will give you the GitHub repository link of this particular program where I'm using Google Colab for demonstration. You will see the concept of this into the README file and this concept. Here, this is IPYNB file. This is Python file, Jupyter Python file, where I have put the demonstration code, and and this is the diagram that we just saw, the conceptual diagram. It is just for your reference. Okay, so you can see that later, and let us jump to the code, right? So like we have, let us I will explain you the code here, and yeah, so let's jump into the code. So this is one small demonstration code that will demonstrate you how the broadcast effective joining takes place. Here I have imported the required features of the PySpark, like PySpark SQL functions, import broadcast, right? So this prepares the small data frame. This is called as category. So I wanted to introduce and join the category of the products of that transaction and want to make a one single frame that will be the result. So the category, we have two columns, category name and category ID, and I have created a data frame. So this is my small data frame. It's a very small data frame that I have 5 rows and 2 columns, right? So I am creating a large database which have almost like 1 million records. Okay, so this is the transaction. This is the table I am creating, where this will give me 10 million records with category ID and transaction ID, which is the same, right? So we are going to do the joining on category ID, right? So after the result, we'll get category ID, category name, and transaction ID, right? So ready? We have a data frame which has 5 rows, a small data frame. We have a large transaction data frame. We call it as like fact table, and we call it as a one. This is a dimensional table, one of the dimensional table, that is customer uh, data frame, data frame. Next one is in order to see the performance, I have to print the start time of execution and end time of execution and the total time taken for the execution, right? So you will see the difference. For that, I am importing the time module here. And before starting the join process, I will start the time, note the time, right? Then there will be united small large df, right? So let us execute this one. And what happening here is, so I am joining the large transaction data frame with the small data frame. Please note this one, large transaction data frame joined with small dim data frame, that is uh, our customer data frame, right? But here is we are using in joining, we are using a option called as broadcast. So we are broadcasting this small data frame and joining that with the large data frame. Okay. This join will be carried out on the common column, okay, category ID, and our join will be the inner join, right? So after that, we'll print this one, and we will measure the this total time, right? So if we print this total time, okay, so what I will do is here I will run this one and let us see what happens. Yeah, so after running, we have got the time with broadcast join. The time we have small data frame with 5 rows, and we have a large data frame count with 1 million records. And after join, we could see there is category ID, there is transaction ID, and the name of categories. Okay, so right now it took almost time with broadcast join 1.27, right? So this is the time taken, and what will be the opposite of this? Instead of broadcasting, what if we do the plain join? Okay, so I have a similar code that works opposite of this. One is we have taken the small data frame, the same, and we have a large data frame, and here we have done the joining without broadcast concept, right? So if we perform this one, what would be the let us see what would be the timing it takes, right? How much time it will take. So the result is ready. So see the standard shuffle for the joining that time is 2.34. Okay, so with the broadcast effective join, we were getting the time of 1.27. See, this is how the difference. We have similar data, same data frames, two data frames we are joining, but this is how effectively we do the joining of the two data frames. So this concept in big data is very important and interesting concept. Here, if we do not have broadcast concept, and we if we have simple join, we land up into the maximum time runtime, right? So this is one of the demonstrate. Hope you had liked this video, and for it will I request if you have any comments or any topic to discuss on this, some interesting facts and ideas on big data programs, please contact me and comment me into the comment section. Yeah, thank you.